Please tell them that they can now connect.
Okay, so we'll have to see. How is it now? So our focus for today's class, will be strictly on your test focus. We'll be looking at the past question. We'll be looking at gravitational physics. We'll also look at if time permits us. We can look at collision theory, conservation of momentum, and we'll look at kinematics. Alright? Please ask them if they can hear me on the live. Let me know.
All right, please comment if you can hear me so that we can proceed. If you can hear me, please comment so we can proceed.
let's begin. So we'll start with gravitation. We'll start with gravitation. We'll start with gravitation. In gravitation, we'll be looking at all the calculations under gravitation. Alright, gravitational physics. I want to exhaust gravitational physics. We'll look at the past question. Dr. Paddy said he's going to repeat question from the past test question. This was the past test question, and we exhaust everything in this past test question in today's class. Alright? We exhaust everything because the same question we brought, the same question is going to ask you guys, apart from the dimension that it's going to add. Okay, so let's begin. Gravitation. I don't know if they can hear me. Please, somebody should.
Yes, yes.
Okay, they can hear me, right? Okay. I don't know. My power bank is dead, so that we don't cut short halfway. Anybody? Baby, I'm using your power bank. It's dead. Jesus. So that. Okay, thank you. Thank you so much. Alright, let's begin. There are four forces that exist in nature. Four forces exist in nature. Four forces exist in nature. Number one, there are four forces that exist in nature. Number one is electromagnetic force. Four forces exist in nature. Number one, electromagnetic force. Number two is gravitational force. Gravitational force. That's number two. Gravitational force. Please, I want you to grab this from this aspect. I said there are four forces that exist in nature. Number one, electromagnetic force. Number two, gravitational force. Number three, frictional force. Number three, frictional force. Frictional force. And number four, nuclear force. These are the four forces that exist in nature. Alright? The weakest of these forces is called the gravitational force. Gravitational force is the weakest force in nature, and it is the most attractive force in nature. Gravitational force is the weakest force, in nature, and it is the most attractive of the four forces that occurs in nature. One law governs gravitational force. One law governs gravitational force. Now, this is where the lecture begins. And that law is called Newton's law of universal what? Gravitation. Newton's law of universal gravitation Newton's law of universal gravitation governs gravitational force. And that law, please take note, this is the first aspect. If you look at the past question, that is the first question that was asked under gravitation, to state Newton's law of universal gravitation. Now, if you're stating Newton's law of universal gravitation, you must use the term of your lecturer. Very important. Now, Newton's law of universal gravitation states that every object in nature attracts another object. Every object in nature, Newton's law of universal gravitation, you must use your lecturer's term. It states that every object in nature attracts another object with a force. Every object in nature attracts another object with a force F. With a force
All right, can you hear me now? Okay. All right, so let's begin. Let's begin. Yes. Yes, I'm just starting now. Let's continue. So we said Newton's law of universal gravitation, but we said we're looking at the test focus. They said they still can't hear me. They can hear me now. When did they forward the message? Is it just now? They will be able to hear me. Can you not hear me? You that? Are you not hearing me? From when you played it here?
Okay, I am not connected.
Okay. You can hear me, right? Alright, so we said that Newton's law of universal gravitation. Please take notes. Alright? I said your test focus under gravitation, you must be asked to state Newton's law of universal gravitation. And I said you must use the statement of your lecturer. Newton attracts another object with a force that is directly proportional to the product of the masses of the object and inversely proportional to the square of the distance between them. Now I said whenever you state the law, you must give the mathematical expression. Mathematically, gravitational force is directly proportional to m1, m2, and is inversely proportional to what? I squared. If you introduce a constant to change this proportionality sign, the constant is g, and this g is called gravitational constant. If I introduce a constant, gravitational force is equal to gravitational constant times the product of the two masses of the object, m1 times m2, all over the square of the distance between m1 and m2. Now, look at what Newton's law of universal gravitation is talking about. Please don't get distracted. Newton's law of universal gravitation is saying that if I have two masses, call this m1, call this m2. Please listen up, don't get distracted. If I have two masses, call this m1, call this m2, separated by a distance r. The distance from m1 to m2 is r. Newton's law of universal gravitation is saying that in between these two masses, there exists a gravitational force, Fg. There exists a gravitational force between these two masses. And this gravitational force is directly proportional to the product of these two masses, m1 times m2, and inversely proportional to the square of the distance from m1 to m2. So if you make the statement of Newton's law of universal gravitation, I said number one, you must give the mathematical what? Expression. And you must tell us what each quantity represents. That is how you score or get the complete mark. If you want to state only law or the statement of universal gravitation without giving the mathematical expression and telling us what each quantity represents, you won't score the full mark. That is the marking scheme. So after doing this, I will tell you that you're supposed to draw this. I'll write something like where beneath this, I'll write where Fg, F subscript G, is called gravitational force. Where F subscript G is called the gravitational force. The unit of gravitational force is what? Newton. Isn't it? Yes. The next one, G. You must tell us what each of these quantity represents. Where G is called the gravitational constant. Where G is called the gravitational constant. G is the gravitational constant. And the value for the gravitational constant is 6.67 times 10 raised to power minus 11 Newton per meter squared per kilogram squared. This is the
value of gravitational constant. And you also tell us that, remember, after giving the mathematical expression, I am telling you what each quantity represents. Fg is called gravitational force in Newton. G, gravitational constant. I wrote the value and I gave the unit. M1, I'll write this. M1 is equal to M2 and it's called the mass of the object. And it's called the mass of the object. Mass of the object, the unit is kilogram. And the last one, R, is the radius or distance. The radius or distance between the masses. The radius or distance between the two masses. And the unit of the radius or distance is what? Meter. Please take note. Take note. I said in your text, when they ask you to state Newton's law of universal gravitation, if you state the law, Newton's law of universal gravitation states that every object in nature attracts another object, isn't it? With a force that is directly proportional to the what? With a force that is directly proportional to the what? Product of the masses. And inversely proportional to the square of the what? Distance between them. Mathematically, you do this, you introduce a constant to take away the proportionality sign, and we have this. Will you just stop here? No. You must tell us what each quantity represents. If you look at the test question, section 3, they said state Newton's law of universal gravitation defining all parameters. State Newton's law of universal gravitation defining all what? Parameters. So if you just state the law and you stop here without defining the parameters, do you get a complete mark? No. This is where the proof of today's class begins. I believe we now know how to state Newton's law of universal gravitation, isn't it? Good. Now, since I know that gravitational force, please listen up. Can I take this off? Can I take it off? If you have any questions, please ask. Your questions can be questions of those streaming online. If you have any questions, please feel free to ask. Can I take this off? Okay. All right. Since I know that, please listen up, listen up. Since I know that gravitational force Fg is equal to G M1 M2 over R squared, R1 2 squared, isn't it? If M1 and M2 are of the same magnitude, it means if M1 and M2 have the same size in mass, I can say that the gravitational force F subscript G is equal to G M squared over R squared. Do you agree? Yes. If M1 and M2 have the same magnitude of masses, I can say that M1 is equal to M2, isn't it? So I can rewrite this as gravitational force is equal to Gm squared over what? R squared. Since I know this, let us get the value of acceleration due to gravity of an object on the surface of the earth. The next subheading, acceleration due to gravity, or you can say acceleration due to free fall. Acceleration due to gravity of an object. Acceleration due to gravity of an object on the surface of the earth. The formula to calculate acceleration due to gravity of an object on the surface of the earth, on the surface of
the earth. Everything I'm doing here is not for fun. It's in the past question.
Alright? It's in the past tense question.
Acceleration due to gravity of an object on the surface of the earth. Now, acceleration due to gravity or acceleration due to free fall, it means I'm looking for the value of g, isn't it? Acceleration due to gravity is g, isn't it?
Yes.
Good. Acceleration due to gravity is the earth pull of an object. It means it's acting, is it downwards or upwards? Downwards. So if it's acting downwards, please listen up. A simple proof. If